Uh, my name is Abhimanyu Kanwar. I'm an AI solutions manager here at Extron SE. It's a semiconductor manufacturing company in Germany. And I just started today in my new role, and I was at the CSA last year, and I continue to be a part of it for my research. And today I'll be speaking more about how technical customer service is impacted, not just general customer service. The title here can be a little dramatic, as you see, the end of traditional technical service, how AI agents can transform this whole domain. But I do believe that there are major changes happening currently, and I think they'll continue to happen in the future. So first, some sort of background as to why this topic was of interest. I started out at my current company as a technical trainer, and I used to train service engineers into solving problems on our equipment, on our robotic systems when they go to different customers. While doing this, I realized there was this big bottleneck that we used to face pretty often, which was basically, of course, as you can see here, the ideal scenario is you have a service engineer on site, they encounter a problem, they resolve it immediately, and then the topic is closed. Unfortunately, however, that's not how it goes, because they have to be experts, so to say, on different equipment, different robotic systems, and they don't just have the luxury to be an expert in just one domain. That meant usually that they will have to go through a lot of documentation to find an issue that might have been documented in the past, similar to what they're facing right now. And so then, yeah, to solve the problem that they have at hand. If they fail, however, they would have to open a service ticket, and because of a global company's big supply chain, they usually, if the headquarters are located in a specific time zone, getting responses to your service tickets can take a long time, sometimes 1 to 2 days, depending on the volume of tickets and the time zone, but it can be a long process to solve issues. Of course, this can lead to high downtimes for the customer, more incurred costs, and of course, that worsens the relationship with the manufacturer. There are other issues that come along with this, of course, like more complications in the spare parts business and negative effects on future collaborations and service contracts. This is a very common issue that I observed during my time there, and as a result, I decided to pursue this research into how AI could help us there. So quickly on that background, how can AI help? I used input data in terms of the technical manuals that we had and also the ticketing data that the company produced over the last couple of years to figure out how to offer solutions to our customers, but also internal employees or service engineers to offer a better customer experience and in the end. So from the customer perspective, to us, it was important to have a user persona so we can offer a personalized approach to this, and also focus of the customer can be differentiated. Some customers are more focused on mass production, some on the research side of things, differentiating between them so to offer a more curated design or personalized agents in terms of the help. For the conversations, yeah, the number of prompts that they'd use to get to a solution, the accuracy, the relevance of the responses, all of that were very important factors for us while evaluating what kind of analytics to take into account. At the start of this, I started with a simple case study in a B2B setting. As you can see, an equipment manufacturer here is displayed providing services or products to customer A and B. In this case, A, we took as a mass production customer and B as a research customer. Of course, a research-focused customer will have different interest points, for example, avoiding major crashes or holding the cost to a bare minimum, while a manufacturing or mass production focused customer has a focus on faster problem solving, faster spare part delivery, etc. So to offer a good product to the final customer in their B2C or B2B further relationships. So this case study was evaluated to offer personalized experience to the customers and to see how AI can help in this domain. As part of this, we defined a few personas. So you can see here we had role-based personas, customer type-based, and region-based. Role-based is a very critical one. So you have, and usually in these manufacturing businesses, you have operators and their supervisors. So you have these operators doing day-to-day tasks and carrying out simple but necessary tasks for the system to run properly, while the supervisors are more responsible for making sure that if there are issues that are coming up, the problems can be solved quickly. Similarly, customer type based, as I mentioned earlier, industrial or research or educational focus also makes a big difference. And finally, region based, Western regions and Asian regions, they can have different, that's just an example of a differentiation, can have different focuses or values. To define these personas, we took three levels, C, D, and T in this case. So the content level was used to limit access to sensitive tool information. So you don't want your operator to work on certain tasks depending on the complexity of the task. And so adapting the information level to the user, or whether it's an operator or supervisor, was critical to such service. Furthermore, descriptive level was important to see how concise or elaborative information can be important. This is something I will touch upon later as well. We wanted to see how detailed people want the responses to be. And finally, the tone level, whether there's a polite tone that is preferred or just a straightforward one. As the base of this study, we tested out two models. One was essentially a RAG model, retrieval augmented generation model, layered with different sorts of additional components like abbreviation layers to make sure the hallucinations are limited, and then an integration layer, which is nowadays known as agentic design. This study was done recently, but back then the buzzword was not that hyped up. So I used the word integration layer for this back then. And then the other one is basically a graph RAG system, which is combining a RAG system with knowledge graphs to offer better understanding of the concepts for the model. The ontology layer in this case, of course, defining how these connections are made. So something like this sensor is controlled by this screw, which can be changed by this screwdriver, and so on and so forth. So you define these sort of rules for the knowledge graphs to be made, and that can be called an ontology layer. And as we discussed earlier as well in the panel, prompt engineering continues to be important. So what kind of system prompt are you giving the models? What do you want out of them? And so on and so forth. So we had study demographics, and this is, I think, to the point of change management. We had a big discussion earlier about this topic, and I feel like this is ever more important within big corporations. So we had an age group of 27 to 64, which is a wide age group, and we covered a lot of different regions, as you can see, in the Western and Asian regions. Most of them were just field service engineers, but some of them were also robot experts who tested out the systems. Average years of experience was 9. I also wanted to take this part from the EU AI Act that was announced in February, that all the employers are obliged to follow these rules, and then that depending on the technical knowledge, experience, and context, the people need to be trained on this technology. And this is something we wanted to also focus on with the study. So quickly on the product that these models were trained on, these models were trained on a robotic system that can be divided into three main components: an end effector, that is the final handler or the gripper, as you can call them, of the robot, an aligner that aligns the components to make sure that they run smoothly, and a cassette for the semiconductor parts that need to go into the reactor. So the models were trained on these three different components and given these documentations as tools, as you can call them, for the AI agents to access information from and respond to the system prompts, user prompts regarding technical issues. We defined some ticketing data. We didn't define ticketing data. We defined some problem scenarios taken from the ticketing data here from frequency analysis. So the most commonly occurring scenarios were taken as examples. Of course, I have here anonymized the result, the ticket and the actual ticketing data of the scenarios, but essentially it went from mechanical issues to pneumatic issues to communication failures and so on and so forth. And these were then tested out with the participants. The results were of great interest as well, as you can see. First of all, I would like to say these are perceived accuracy and hallucination rates. That means the users or the service engineers were asked for their opinions on which results they consider to be accurate or inaccurate. Similarly, the hallucination rates are also perceived data. They're not some semantic comparisons, because I do believe in the end, it's more important as to if the final user is actually benefiting from the information, rather than just doing semantic comparison to proper answers that can be considered correct. And so we saw accuracy results of 96 to 97%. So GraphRag just slightly outperformed the RAG system. But more of an interest was the hallucination rate, as you can see here. Because more often than not, when the graph rack system or the second model, when it failed to respond to a user query, it would just say that it cannot do it. It said that, I don't know the answer to this question, sorry, and so on and so forth. While model one, or the base RAG model, continued to, push out responses even when it was not sure, leading to hallucinations. Of course, this can be a big factor for companies which are dealing with sensitive equipment or sensitive sensor systems or expensive equipment as well. And so even if the accuracy rate is similar, they would not want to risk their models hallucinating, and in the end, the service engineers making mistakes. So for them, this difference can help make better data-driven decisions into what model to deploy for their companies. What was also of high interest, we saw a big change in time to solve for these issues. We saw that without the model, on average, the engineers needed 29.5 minutes to look for the information, make sense out of it, and know which actions to take. While with the model, it was down to 20 seconds. So that was a dramatic shift from the usual time spent on these tasks, and that's the main reason I do believe that technical customer service will continue to change in the coming years, and I think it's a dramatic shift from how we used to do things in the past. Model preferences also showed a very clear preference for GraphRag solutions. 77% of the users preferred the second model, while 23% preferred the first one. So it was a clear win for the GraphRag system, which showed better understanding for issues that were coming up. And a tone preference was also compared. Mostly direct tones were preferred by most engineers. They just wanted an answer. They did not, focus so much on the niceties of the models, and were more inclined to just focus on how direct the answers were, what they could do with them, and so on and so forth. Interesting results were also seen in terms of age and total tone preference. As you can see, from 25 to 35, the tone preference was much lower in compared to 35 to 45, and then people older than the age of 45 had a very balanced view on which tone they preferred, but a clear trend was seen in terms of the data. Similarly, in terms of education level and total tone preference, people who went to university were more likely to prefer a direct tone, while the people who didn't go to university were more likely to prefer polite tone, which is also an interesting finding in terms of demographics. And I think this will also help topics like change management and seeing to what extent do I need to adapt my personalization to make sure that the people, are more willing to accept this new solution. Age and education effects were also interesting. Anthropic recently announced this economic index, which said that well-educated professions were more likely to use AI. However, in the study, we saw that the people who didn't go to university had the biggest benefits, because their time to solve without the models was 37 minutes on average, while people who went to university had an average of 23 minutes without the model. So people who benefit the most are actually the ones who didn't go to university. So I think that was also a very interesting finding here. One last data point that I would like to mention is that, of course, the years of experience, the more years of experience someone has, the less they would benefit from this, of course, because the time to solve will not be changed much. That means companies looking to make new hires or starting new product lines will benefit a lot from such solutions to improve their knowledge base and to improve their employee performance on different tools. To the point of descriptiveness, we noticed that there was a borderline significant result in the number of words and preferences. So people, or the engineers that we tested these models with, preferred to see all data, all relevant information at one go. before deciding that this is the answer that they prefer. So that was interesting to see as well. They liked more descriptive models, and they wanted to see all relevant information at the same go. So potential cost reduction, this was also a very important finding. So I think Stuart mentioned this earlier, that the need for experts continues to go down with the inclusion of such models or solutions. I think he had a number, roughly 15 to 20% of less experts are required now in the field because of this technology. And similarly, I wanted to point out that when a service engineer fails to solve an issue and requests an expert, a lot of travel costs are added to this, and of course downtime as well. So on average, within my study, I saw that the travel costs range from 2 to 5,000 euros per downtime or per issue that popped up, which can of course add up very quickly if not solved remotely. And of course, because of downtime sensitive industries like semiconductor, we also noticed that 1 day of downtime, additional day of downtime for any tool that we have can cost the customer up to 100,000 euros, which is a lot of money. And so in that sense, ensuring quick and precise resolution is very, very critical in such industries. And I would like to close now with the future of AI agents as I see them. So I feel these factors are going to be more and more important: the latency, the domain-specific agents, and more. In terms of latency, of course, these RAG, graph RAG lookups are very, very good solutions, but they can introduce delays. And even they can sometimes hinder seamless user experience because they have to wait for responses to occur. So I do believe we need to continue to move in the direction of faster retrieval techniques. I think there's already good solutions coming up in that direction to offer a faster, resolution time to the problems, but also a better user experience. Also, on the end of deepening domain specificity, I do believe fine-tuning the models, or having domain-specific agents, are going to be more and more important. Whether this is distilled models, smaller models, helping solve issues, or if it's bigger models just fine-tuned to certain use cases. I think this will continue to be more and more important, and this is something I also observed during the tests. Finally, expanding capabilities. I think in the future, multimodality will be more and more important, as different videos and repair guides, different part photos, and so on and so forth will continue to be more and more important, in addition to just ticketing data and manual designs as well. And final point, of course, proactive and predictive support. So as Stuart mentioned earlier, of course, the self-healing stage could be very important as well, in which before the issue even occurs, the data is, of course, analyzed by the AI agents, and important messages are then passed on to the users. I think that's going to be a very important field into the future. So that's it from my side. Thank you so much.